Lesson 3.7. What we're going to be doing is we're going to be solving for formulas and functions. So we're going to take different equations and solve for certain variables. Before we do that, though, I want to review some problems that we have done so far in Chapter 3. So I want you guys to take a few minutes, and I want you to solve for x. One of these answers will come out a decimal, so I want you to round to the nearest hundredth. All right, Valentina, tell me what you did on this first problem to solve for x.
So I added 3 on both sides.
Very good. Add 3 to both sides, and we get 2x is equal to 12. Blaine, what am I going to do now?
Divide by 2 on both sides.
Very good. Divide by 2 on both sides, and x is equal to 6. Perfect. Okay, now let's do the second equation. William, what did you do to solve for x first?
I added 1x to the side.
Okay, he added 1x to both sides because we know there's an understood 1 there. And we have 6 equals 4x plus 25. Now let me see you raise your hands. How many of you did something different first? It does not matter what you did first. Your middle steps are probably going to be a little bit different than ours. But at the very end, we still should get the exact same final answer, which is what I'm most concerned about. Vincent, what do I do now?
You subtract 25 from both sides.
Very good. Subtract 25 on both sides. What's 6 minus 25?
Negative 19.
Negative 19 is equal to 4x. Zachary, what am I going to do next?
Divide by 4x on both.
I want to divide by 4 on both sides. And what is negative 19 divided by 4? Remember, round your answer to the nearest hundredth. Vincent?
5. Negative 5.
Not to the nearest whole number, to the nearest hundredth.
Oh,
Negative 4.75.
Very good. Negative 4.75. Make sure you pay attention to what it tells you to round to, okay? Because your answer can be wrong just by not rounding correctly. So we did all of that because in today's lesson, we're going to be using the exact same procedures to solve equations that we do any other time. The only difference is we're going to be working with more than one variable. Now, what this gets you ready to do is it gets you ready to graph in Chapter 4. Okay? So look at example 1 here. It says, rewrite the equation in function form. What that means is get y by itself. So when it says write the equation so that y is a function of x, that just means get y by itself. So we want our answer to say y equals blah, 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 whatever it may equal. Now, obviously, when we're working with more than one variable, we are not going to be able to say y equals 5 or y equals 7 because I don't know that. Because in order to know that, I got to know what x equals, and I do not know what it equals. So what we're trying to do is we're just trying to get it to say y equals 2x plus 5 or whatever the equation may be. Okay? So what I want you to start off by doing is circle the variable that we want to get by itself. So what am I going to circle in this problem? Y. Now I need to look and find out what do I need to move that's on the same side with y to get it to move to the other side, William?
3x.
The 3x. Now here's where people get confused. People say, oh, 3 and x are being multiplied, so I divide. No. If I wanted to split up the 3 and the x, then I would divide. But that's not what I want to do. 3x is a term, and the entire term needs to go from one side to the other. Well, in order to do that, all I do is the opposite. So 3x is positive, so what should I do to 3x? Subtract it. Can I do 4 minus 3x and get 1x? No. Why not? Because they're not like terms. So, here's how I want you to write your final answer. We know that y is by itself, but when you are writing the terms on the other side, I always want the term with the variable first. So I want it y is equal to negative 3x. Then what is 4, positive or negative? Positive, so 3x plus 4. Okay, so let's look at this next problem here. They want me to rewrite it so that y is a function of x, which just means y has to be by itself. So let's circle that variable. But what is in front of the y? Negative. We cannot forget about that. What I cannot do is say, oh, I'm going to divide by -1 first. Excuse me, because it does not work like that. Okay? What should I move first, Caitlin? The 2x. And how would I move it?
Subtract it.
Very good. Subtract it. So I subtract 2x on both sides. Can I do 9 minus 2x? No, because they're not like terms. So now I have negative y, because I cannot forget about the sign, equals negative 2x plus 9. Sarah, what am I going to do now? Because is y by itself? No, it's not. So what should I do?
Divide by -1.
Very good. Divide everything on the other side by -1. Divide everything on the other side by -1. So now I've got y is equal to positive 2x minus 9. Now here's why we cannot start off by saying, oh, let's just divide. Because look at this problem right here. I'm going to rewrite the original. If I were to say, okay, let's divide by -1, what is being left out that does need to be divided by -1, Vincent?
The negative on the 2x.
The 2x. If I don't divide it, then it's wrong. That's why we don't ever want to start out by doing that. Remember, we're working in reverse order of operations. Okay, look at these next problems. They get a little more in depth. We're still solving for y, so I still want to get y by itself. I'm still following the same exact order that I have been. But there's something in front of y this time that was not there last time. There's an actual number there, other than 1. So, Zachary, what should I do first to this problem?
Add 2x.
Very good. Add 2x to both sides. We know these are not like terms, so I just write them side by side. What has to be written first? The 2x. So now I have 3y is equal to 2x minus 6. Now, what do I have in front of my y that has got to go? William? The 3. And how do I make it move from one side to the other? Divide. Very good. So I divide this side by 3, and that means I divide everything on the other side by 3. Just how we divided each term by -1 last time, we divide everything by positive 3. Now, can 2 be divided by 3 evenly? No. Never, ever, ever write this term as a decimal. Does everybody hear that? That is going to make so much more sense once we get into chapter 4, but never write this term as a decimal. We always want to leave it as a fraction. So we have 2/3 x minus, what's 6 divided by 3? 2, or -2 because we have that minus. So there's my equation in function form. Y equals 2/3 x minus 2. Okay, so this next problem here, William, what am I going to do first? Subtract 2x, perfect. Now I've got -4y is equal to -2x minus 10. Jarrett, what am I going to do now?
Divide by 4, -4 on both sides.
Very good. I'm going to divide everything by -4. So now I have y is equal to, do I need to reduce this fraction? Yes. The answer is yes. If it is a fraction that can be reduced, you need to reduce it. So what is -2 over -4 going to be reduced to? Positive 1/2 x. Then what is -10 over -4 going to be reduced to?
-5/2.
Positive 5/2. Or you can write 2.5. The reason why we know it's positive is because a negative divided by a negative is always a positive. So here's my answers. Last example, and this is what I want to talk to you about for a second here. On this example, people get really confused because they see a bunch of letters. But what I want to tell you is that these letters are absolutely no different than numbers. We are going to follow the exact same order, the exact same pattern as if I had numbers in one variable, okay? They want us to solve for the indicated variable. What that means is whatever variable they tell us, like in this first problem for L is what I want to get by itself. So my final answer should say L is equal to whatever it may be equal to. Now, obviously, we're not going to say, oh, L is going to be equal to 6 or L is going to be equal to 10, because in order to do that, I'd have to know what the other variables are. And I don't know what they are. I mean like specific numbers. I don't know what they are. So, what we would use this for, this is the formula for area, and we know that area of a rectangle is A equals length times width. So what if I were to give you the area of the rectangle and the width of the rectangle, but I don't know the length? How am I going to figure that out? This is all we're going to do. Are you ready? It's very simple. If I want to get this L by itself, what's happening between the L and the W? Multiplying. So how would I get that W to go to the other side? Divide. You say, wait, can we do W divided by W and it cancels out? Yep. Whatever I do to one side, I've got to do to the other. So I know that length is equal to A divided by W. And that's all we're doing there. We just want L to be by itself. Because I can't solve anything, there's nothing left for me to solve because I don't know what any of these variables equal. But it's ready for that type of problem if it were to be given to me. Okay, so this second formula, they want us to solve for F. And what this formula is used for is if we know Fahrenheit and we want to convert it to Celsius. So, what they're asking us to do to solve for F, that means we know Celsius and we want to convert it to Fahrenheit. So I need to change my equation accordingly. Now, this equation is where so many people get confused because they're like, fractions, I don't know, I'm tapping out, I'm done, I'm not even going to answer this one. Well, let me show you something here. What if I were to give you this problem? If I were to give you this problem, what would you say you need to take care of first, Stephanie? You have to multiply by the reciprocal. So I multiply by 2/5, 75 by 2/5, and then I can solve it. We'd say 5 goes into 5 one time, 5 goes into 75 15 times, and we can multiply and solve. Now, we're not going to keep going with this, but I just wanted to show you. You know exactly what to do as the first step on this problem, so guess what? It is no different when we have more than one variable. What am I going to have to take care of first? The fraction. I've got to do distributive, I do not want to do distributive property. Instead, I want to multiply by what? The reciprocal. 9/5. Cancels out. Whatever I do to one side, I've got to do to the other. Can I multiply 9/5 times C? Nope. So I just write 9/5 C is equal to F minus 32. Now, is F alone? Is it all by itself?
No.
Not yet. Mary, what am I going to do to get F by itself?
Add 32 on both sides.
Very good. Add 32 to both sides. And I get, well, let me ask you this. Can I add 9/5 C and 32? No, because they're not like terms. If that 32 had a C attached to it, absolutely, they're like terms, but it doesn't. So I'm going to write 9/5 C plus 32 is equal to F. Now, is F all by itself? Did I solve for Fahrenheit? Yes. Now, if we wanted to write it in proper algebra form, it would be F equals 9/5 C plus 32. Either one of these are correct equations. All right, last problem. What they want us to solve for is R. Now, this is a formula to find interest. The formula is interest equals principal times rate times time. And what they want us to solve for is the rate. So, for instance, if you got a problem where you know the interest, you know the principal, and you know the time, but you don't know your rate, that's what we would use this for. Let me ask you this. This problem actually is very simple. It's nothing different than the very first one we did. There's only one slight change, and that is that there is one more variable. What is happening to the P, the R, and the T? Vincent?
They are multiplying.
They're multiplying. So if I want to get the R by itself, what do I need to do?
You need to divide.
Divide, and let me show you a shortcut. When I've got more than one variable being multiplied, I can divide by both of them at the exact same time. So I divide by P and T, both together. So, did I get R by itself now?
Yeah.
Yep. R is equal to I divided by PT. Or you could have I divided by PT is equal to R. Either one of those are correct. So that is how we use formulas and functions to solve for variables.